our plan. I think next on the list would be to make a small Python binding. So for that, we have to use something which is called PyO3. So it's to create bindings from Rust code that you can use in Python. So first of all, what we have to do is to create a virtual env. Where do they do that? Okay, they do that in a file, in a directory. So I'm still in the project. I mean in the root of the project of my workspace, sorry. So I can create a directory here for sake of simplicity. I will just call it Python. So mkdir Python. Probably I don't have virtual env installed. I'm gonna install what I need. Okay. Okay, UV is not in Ubuntu. Ah, yes, but I can do it with the Python command line, right? Does anyone know the command? Easy. I don't even have Python installed. Oh, yes, I do, but just need to do that. Damn it.
Yeah, maybe just remove the version, like just Python 3 valve instead of Python
Pardon?
3.12. Maybe remove the point 12. Ah,
I guess this is the issue.
mm.
This was the issue. Okay, sorry for that. Now it should work. Or not. So, okay, so we are in our virtual env. And now, what does it tell? It tells that we should install a tool called Maturin. Okay, great. So now I think we should do some sort of Maturin init, yes. Maturin init will just prepare for us a Rust project so that it is like friendly for Python bindings. So Maturin init. So it asks us what kind of binding we want to create. In our case, it's PyO3. That's it. We can look into our IDE. So it created like a cargo.toml file. So it took like the name of the directory to name the package, which is like not a good idea. Let's call it like binding example. And here in the lib section, this is actually a section that you can specify in your cargo.toml file, and that kind of changes the default cargo is taking. So here it says when you build a lib, the name of your lib will be Python. Here we have to change it because it's also going to be the name we will need to import in Python. So we have to change that name. So how can we call that? We can call it the same binding example. And cdylib, and this is just telling basically in what kind of ABI, if I'm not mistaken, we want our lib to be compiled, and this way it's to have it with C kind of exported function, if I remember correctly, because that's what Python need when it's loading an external library, and especially the ones compiled and the one which are not Python. And in this crate, we will need the PyO3 dependency. We see that Maturin also created a PyProject.toml, same with the name of the crate, probably something we want to change. So if you just want something different here, when you generate, you do a Maturin init, you just do it in a directory which is not called Python, which was maybe my mistake. Or you can also, I don't know if you have seen, when you do Maturin, there is a new command that you can use, and that creates directly the directory structure with all the file contained. That's not what I did. I did a mkdir and then I did a Maturin init inside. Okay, so here we go. we reviewed like the cargo.toml, the PyProject.toml, which is the one used by Python, and that will be used for publishing on PyPy if we want. So in lib.rs, we have a snippet, and which is showing like a basic Python function and Python module. So this is called mod Python. So here we should rename so that it looks like this binding example. Otherwise, we will do import Python in Python, which is weird. This is basically the import name of the module, and it needs to correspond to this name. So, okay, that's what we got. Everything in Python, in Pyo3, works with procedural macro. I don't know what they do exactly, but I imagine what they do. They transform this Rust code to export it in such a way that it's valid C exports and that it's also fulfill like the requirements Python is expecting for dynamic libraries. So in Rust, of course, you can define C export. I don't remember how we do, but there is a way. We can check. So I think, yeah, we should include like, we should include something that says no mangle. So don't like mess up with the function name. But also we should put that kind of keyword like, yeah, no, I tried, it doesn't work. The problem, yeah, because you need to define like your prototypes, and then you should define your functions like that. So I guess what partly of what this procedural macro is doing is defining some C style exported functions. Even though Rust code is running behind, I mean, the C exports must be used, I think. So that's pretty easy. So far, we haven't used the library we have written, but we can already try this function. It should work. So how do we try that? We do Mathurin. There is a specific command which is develop, which is actually building the binding and installing it in the virtual environment. If you just do like Mathurin build, it's not going to work because it's just like building the library. It's not installing it in the virtual environment. So always use develop when you are on your machine. Okay, there is an issue. And the issue is because we didn't put like the Python directory in our workspace member. So here it expects like a directory name. So this is the directory name, Python. Okay, it's compiling the stuff. Okay, I cannot like split. My God, cannot have a split view.
Excuse me, Quentin, can you show again your cargo .toml, which defines the workspace?
Yes, I can. So just you need to put
Okay, it's like that.
next to the two others, you need to put the directory there where you have your Mathurin
And
project.
if I have created a Python in the my app directory, is it
Yeah, it's not going
can
to
it run like
work.
that?
No, it's not going to
No?
run because it's like yeah, it's kind of nested. Uh, Maybe if you point it there in the members, but I don't guarantee it's going to work.
Okay. Okay. You don't it's better to have the Python directory outside.
Here it's better. Why? Because the idea is that we are going to use the word count method that we have defined in IO example. And I'm not sure if you created like under my app, you would be able to go back and get the dependency. Yes, you should anyway. But yeah, I would in theory put it at the root. Why?
Mhm.
Because yeah, it has nothing to do with the binary crate you have there in my
Yeah.
app.
Yeah.
So yeah, I would definitely recommend to put it at a place where it makes sense for your workspace.
Mhm.
Maybe an IO example would make sense, but yeah, I tend to prefer like clear. Whenever you don't need like nested crates and workspaces, I think sticking with one layer is okay. Maybe for like super big projects and so on, you do like nested crates and workspaces, but for very simple projects like that, you can put everything at the same level. Is that okay?
Yes. Yes. Thanks a lot.
Okay. Okay. Okay, so we have seen that it actually installed compile without any issue. So now I can go there. Okay, so I just went in the virtual environment in my new terminal so that I can open a Python interpreter. I will actually install that. This is just a bit more friendly interpreter. Okay, so now I should be able to import, how I call this, binding example. No issue. And from that module, I should be able to call the sum as string function, which is defined as a py function and which is taking and expecting two usize integer and returning a string, a Rust string, which will be converted to a Python string representation. And this is like a specific type for returning errors in PyO3 modules. So it's a Py results and it's expecting what? So it's actually yeah, this is something you might see at several places, is like some libraries that you might be using are redefining like a specific result type. And here we see that it's just an alias there, pub type by results with generic T. It's an alias, more or less. It's type definition for a result of type T, but and a specific error, which is PyErr. That's it. It's just that one of the generics is fixed, and it's fixed to a PyErr type. And here, as the first generic, we just expect to return the OK value type, let's say. So sum as string is summing the two usize and returning the string representation of it. And that's what we should get. Finding example dot sum as string, we can even autocomplete it. So it's expecting two integers. That's what we put. And we get a string back. We can even verify that it's a string. Okay, it's a Python string. What happens if we put like something else than an integer? We get a type error. Argument B string object cannot be interpreted as an integer. So you
Sorry,
see,
Quentin.
like the PyO3 stuff is not only just generating the exports, but also like format and do argument processing and result, let's say, how to say, correct error wrapping so that everything is okay with Python, and everything in very little Rust code. Someone wanted to ask something?
Yes. I have an error when trying to execute Maturin develop. It's
Ouais,
complaining
yes.
about a missing field package in my cargo.toml.
Missing field package.
Yes.
Maybe there. This is
On the
like the cargo.toml in
Python,
the Python directory.
I
Does
have
it look like
the
this?
package, but I don't have the lib. I have a package and dependencies, but you
Because
think it's
and you
maybe
have
I'm
this
missing lib?
as dependency?
No. Okay, no, I don't have this.
Because you didn't do like the Maturin init.
S-
You did
n-
like cargo new or
I've
something like
no,
this.
no, I've done Maturin init, and and it prompts me like, do you want this or this to init the Maturin? Um, I I run Maturin new Python and which kind of bindings to use, and I choose PO3. But it
This is strange. Because if you chose like Pyo3, you should get like all of this generated for you. You should get, that's what I did. I just did like
Oh,
maybe I
I
can.
was looking at the wrong directory.
Okay.
I look at Python. Yeah, I have exactly like yours. And for lib, I I've kept the name Python.
Yeah, you
Is it
should replace or
replace Python with another name?
yeah, replace with another name, yes.
Okay.
Yeah, like a binding example or whatever you want. Just the only requirement is that this name in lib is the same as the Python module you are defining.
Mm, mm,
Otherwise,
okay.
it's not going to work. It will
But I
complain
still
that cannot find the module or something like this.
yeah, I still have the same error. I'm on my root directory of the project, and I type Maturin develop, and it tells me like it has an error parsing the TOML at the first line where I define the workspace. It tells missing field package. I don't know, but I will.
Yes, it's probably because one of your cargo.toml, I don't know which, maybe you have the path or whatever in your terminal, you are missing this probably. You're missing like the
Uh,
package stuff.
no, on every cargo.toml I have a package. But don't
Okay,
worry, I will
okay.
try to debug myself. Thanks.
Um, so now, okay, this is like just a very small example with a snippet of Pyo3. But in practice, what we would like to do is actually maybe use some libraries that we have written in Rust and provide some APIs to it in Python. And that's what we are going to do. So we are going to use like the word count method that we have defined here in IO example, and we are going to use it in Python. So nothing easier than this. We can just copy paste. Small note about Python. If we want to use generics with Python modules and so on, it doesn't like it because I think it doesn't have like the code to handle this properly, and generics is something which is very Rust related, so there is no way to handle that correctly in Python. So if I try to do this, essentially the same stuff I did for Rust, it's going to complain. And it tells me fail to resolve function word count is not a create or module. No. Okay. Maybe why? Okay, I don't get maybe the good error because of this. Yeah, Python functions cannot have a generic type parameter. So we have to do something else. In this case, since Python doesn't have like generics, we would have to support like the equivalent function that we have in Rust. We would have to say word count, I don't know, string path, word count path, blah, blah. But for simplicity, we could just put a path. Cannot be used as a Python function argument. Okay. So we could just use a string. This actually Python Pyo3 knows how to convert a string into its Python equivalent, which is a str. It should work anyway. Our method should return what the U64. That's what we did. So IO example. Yes, something is missing. We have forgotten to put the dependency to our library. So it was IO example. Then we have to use a path, and it's like dot IO example, right? And this should make it work. We always have to think about this, otherwise we won't be able to use the functions we have defined in our library. So IO example word count. And since we have defined like a word count method in Rust that takes a generic, which also understands string, we should put P. Or, yes, what is happening there is it's telling me basically that it cannot transform a stdio error, which is the one returned by word count, into a pyo3 pyr type. So what we could do one very powerful function of the Rust result. This you have to see it as the Rust results. Basically, this is just an alias to it, which is map error, which is used to transform one error type into another one. But we have to provide what we have to transform the error into. So we want our IO error, and we want a pyr, and pyr, what does it have? And does it have an IO error? Pyr new, what is it expecting? Okay. Okay, maybe we will use something, maybe an easier notation. This is a bit cumbersome. So the errors, the way it's taking errors is like this Pyo3 exception. So likely in Pyo3 exceptions, we are going to find all the Python error types that we are used to. So we are going to import it, Pyo3 exceptions, and should be like IO error here. So we are going to transform our IO error into a PyIO error. And PyIO error dot new error. Does it expect a string? Does it work? Okay. And we can just put like a dot to string. So what does it do here? It's PyIO error is actually a Python specific error type. We are using the new error method, which, as you can see in the prototype over here, is returning what we expect, so a PyAir. And in the parameter, it expects something basically that can be printed on Python side. And what we are going to put there is basically, for simplicity, we are going to put the string version of our IO error, Rust IO error, and we will see how it behaves. Why does it tell me this import is useless? Okay, I remove, and I remove too. Okay, it imported there in the module. That's why. Okay, so let's run Mathurin develop again.
My error was because I was running Mathurin develop at the root directory instead of the Python directory.
Yes.
My bad.
You have to run it inside the module, the Python directory or Python binding directory. So there, it compiled very well.
Anton? Sorry.
Yes,
I was running
Andrea.
in the directory of the module, but for me, there is an error. Maturing failed caused by could not find the virtual env conda environment. I sent in the chat two problems. Maybe you could look on it.
Did you create the environment, the virtual environment, and did you load it?
Not sure. Maybe I missed it.
So you should do it. If you don't do, it's
What
not
is the
going to work.
command for this?
Did you create it, the virtual environment?
You mean poetry or something like this?
This is like the command to create the virtual environment.
Okay, Python. Okay, minus. Just a second. I edit. Okay.
Okay.
Yes, minus
And then you have to
dot env. Okay. Inside of the module, right? Python module.
yes.
And then I go Matillion develop, right?
No, you have to load the virtual environment by sourcing it. You type this.
Source env bin. Okay. Thank you. Activate. Okay. And then I do Matillion. Okay, now it's good. Finally. Oh, thank you. It's compiling. It's compiling. I don't know yet. Thanks.
So now we can, if you want to reload the module, you have to close the previous interpreter and reopen it again, unless there is a way to override like imports or reload stuff. I don't know how to do that in Python. Usually I just like kill the interpreter and run it again. So binding example. And now we have like the word count, which should be exposed. And we could just word count our cargo.toml. And we get like 37. So here is how we actually manage to use our library function we have defined in Rust and create like the Python binding for it. Important thing to remember is that you will have to map errors. We could have created like a from trait for PyAir. But here this is not what we want to do. Why? Because we don't want maybe all errors. Yeah, actually, yes, we could have done it like from IO error and return this. Maybe it works seamlessly if we do that. So impl from, yes, but we cannot do that. We cannot do the impl from into for, sorry, because neither IO error nor PyErr is defined in our crate. That's why we have to use map_err. Okay? You remember when I said like in the trait chapter, whenever the conditions needed to be able to implement a trait is either we define the trait in our crate, or we define like the structure we want to implement the trait for in our crate. And here we are in none of these two situations, and this is why we cannot implement the from trait for PyErr. Okay, is that clear for everyone? So in this case, this is why we have to transform the IO error with this method call. So yes, I just didn't try to do it because the compiler would complain. Okay, we can try to do it on a non-binary file, non-UTF-8 encoded file, and see what's going to be the output. Okay, I don't see anything because of that. And we get like OS error, stream did not contain valid UTF-8. So here, to be honest, I don't think like this error is like the proper one in Python. So if we would be very picky and we want to have a specific Python and the correct Python error, encoding error, to be honest, for this implementation, we would have to change a bit our library and return separate errors and not like a single error type, because here we see that a word count is returning always like a IO error. And here, if we want to handle separately the encoding error or like non-existing file and so on, we would have to return a more fine-grained error than just IO error. And this IO error, the one from UTF-8 encoding, is returned by this one. Why do we need, and why is it interesting to implement and use Python, Rust binding in Python? Let's implement the same function in Python. Sorry. Yeah, it will be a more simplistic implementation, right? Because we cannot split on white space in Python, or maybe if we have some Python pros here.
I mean, that would be the way to do it, like split with like space like that. That's yeah.
This would be more or less the same Let's try. Maybe it's going to complain because of the encoding, no?
It should not. UTF-8 be the default.
Okay. I trust you. Okay. We are missing some words because we don't split on end of line. But this is just for the purpose of we are just timing like the Python function and maybe try to do the same with this one. Of course, we have to use the same file if we want to have comparable result. Maybe this is not the best example. This is actually slower in Rust, okay. Maybe not the good example. Yes, bad example. I don't have any idea why.
I mean, for stuff like that, Python is very optimized. Like you don't have to run as much. Like loading the whole Rust environment makes sense that it's just taking longer.
Yeah.
Like for something really small like that, you wouldn't do it in Rust. Like that's not really the point.
Okay, so it doesn't work well for this purpose.
I mean,
But
it's as it makes sense. It's just as an example, it's perfectly fine. Like it's yeah, like there's
so if
no
you want
issue
to
there.
time it, you can do like that. And just know that maybe Python is actually faster than using a Rust binding for some very simplistic operations like that. So for this example, this is not a good example of using Rust for performance. Good to know. So in this Python module, we have seen that we can create like just Python function, but for most use cases, this is not enough, I guess. So we might want to use Python objects. I don't remember exactly how do we do that. We have to define a PyClass. We have to define a structure. Let's, I don't know, put a field which is, yeah, maybe just take a person. Maybe better example. Name, string, age, option, U64. For the initialization, we have to say PyInit, if I remember correctly. Oh no, new. This is the keyword, no? Oh, I have to check in the documentation. I don't know it by heart. The PyO3 documentation is pretty good. You have like lots of stuff. Ah, no, I have to buy class. That's what I did. Buy class, yes. Da-da-da. Okay. Yes, this was new. Ah, okay, I have to put like py method. That's why. I have to put py methods on top of the imp block. And like this, it should work. We can, of course, combine with our derived traits, as we have seen. I don't remember how we can do that. Yes. So basically here I'm just returning a default structure for person, taking default value for string, which is going to be empty string, and default value for option U64, which is going to be none. Interesting thing is that you can use PyO3 to generate the getters for your structure members by using this attribute macro on every field you want to be gettable and eventually settable. So you can either put get set or just get, whatever. Let's try this. We will be able to get the name and we will be able to get and set the age. So this is the way you define a structure. You create like this will actually generate the Python init equivalent. In itself. No, I don't remember. Do we have to put the self in Python? Yes.
Yes.
Yes. That's it. We could also create a interesting. We could create this function. Yeah. Maybe we want to separate two cases here. If there is an age or not, which would be better. So this is the case where the age is specified. And otherwise, we just say I don't need autocomplete. and their self.name. Okay. So let's see how it works. Small note, it's not going to work at all because if you see, we have defined it, but I think we need to some sort of expose it here in the module. This is where we define our Python module. So we have to use it. There are different ways to expose structures. Where is it? There is one. Let me find it. Okay. Maybe there. I just have to find. Okay. But I think there was a way to. This is one way. But I thought there was another way to mention we wanted to export basically to a Python object. Okay. Okay, just we will use this one. It's going to be easier. So actually, this is one way to manage like the exported functions and stuff to your Python. This is another way to do it. And this seems to work for function, but I don't find back like the documentation to expose structures via this declaration, let's say. So I'm going to use this one and I'm going to comment all this code. This, we have to change it. This needs to be our module name because it's the Python Py module that we declare. So this needs to be binding example. What's the issue? No method add class found in the current scope. Okay. What the hell is this? My class doesn't exist. Okay, person. But I don't understand. What the hell? Why it doesn't work? Let's look at the documentation. Or maybe I will just be super lazy. I will look into another project of mine and try to understand what's the difference. Okay, yes, I see the difference. And I don't understand why this is not documented like that. And v12.3. Okay, this is an old version. I don't know how I managed to go there. We are version 27.0. Probably I ended up on that documentation because of a search engine. So, okay, let's understand what we are doing. Python classes. Okay, we are good. This is where we should be in line. So we should be able to do that in theory. That's what I was looking for, actually. What I wasn't able to find. Okay. Sorry about that. I was on the wrong version of the documentation. So, by module export that I will put on top. And what is the syntax? It's just use. Super, it's like a specific keyword to say like the module on top of this one. And should be person, right? And now we have exposed like the person structure, which will be usable as a Python object. Let's try to compile it. So
Can you show again your code, please, Quentin?
what do you want to see?
Just the part with
This one?
module export.
Okay. So yes, if you look at the so I just added that compared to the previous one. These are the two lines I've just added.
And the use PO3 also, I'm missing.
Which one? On top, this slide should have
Online,
been.
online
This
30,
didn't move
38.
from the beginning.
Yeah. But you add also the lane 38 exception.
Yes, this was like for this. This was for
It
the
was
previous
already.
example. Yeah, it was
Okay.
already there. I've
Okay.
just added this. This didn't change. It's for this example. Is that fine?
Okay.
Okay, it worked.
Okay.
The compilation worked, which is already a good thing. Let's import the stuff. Import binding example. Okay, we can use the person. We can use it like a regular Python object. We have generated like the getter and setter. So we can access the fields as we do in Python when yeah, as if it were a Python attribute. Person.age, and you see like the option. The option is directly translated into none in this case because it was empty. I don't know how is like the getter age equal 42.
But we
And
have okay. I have an error like for the name tells that attribute name of a built-in person object is not writable.
The name of the person object is not writable. Ah yes, because we didn't generate the setter.
The setter.
It just we did
Yes,
the test. We
yes.
said okay, we generate just get for name and get set for age. And indeed, if we try to do a person.name equal John, we get like an error. We could just print a person, which is actually calling our str method, exactly the same as you would do in Python, right? So which is also very convenient if you want to implement like the string displaying from Rust objects into Python. So here we are. We can just maybe change this init function so that it takes a name as a string slice or string reference, we don't care. An optional age. My God. Okay. This is much more friendly. Okay, let's say now that, yes, we cannot change the name, but we can change the age. Ah, yes, it's complaining because it's obviously expecting a string, and I provided a string slice. So as we have seen, there is a method from mapping a string slice into a string objects. So since here the compiler knows the type of the name fields, it can infer it, and if we do like into, it will call directly the string from string slice for this type. So this is a typical use of the into method that we have seen on Friday. Let's call that. Let's compile that again. Okay, everything works. I restart it. So now, if I do that, I should have an error missing two required positional arguments. So name and age. So We will call him John. So name is John. Age is none, has no age. So my name is John, and I didn't specify my name. So this was our specific implementation. If we do john.setAge of .age equal, I don't know, how old is he? 36. And I'm John, and I'm 36. So this is how we can actually use custom Rust structure and map them into Python friendly objects. You just might be aware of some restrictions. Is that those structures, the one exposed to Python, cannot contain references. If I put like this, it's going to complain in theory. No. Yes, maybe. Because it tells me that it cannot like handle lifetimes, because this would require a lifetime, for instance. Maybe it doesn't complain for the moment. Yeah, it's missing lifetime. But if I put like a lifetime here, it's gonna tell me like your structure cannot have lifetime. This would be like the correct definition for the structure, the Rust structure definition, but tells me a PyClass cannot have lifetime parameters. So this is just not possible. So in Python, basically, you always, in PyO3, not in Python, you always have to define structure owning the data and not actually borrowing data from others, simply. So no references in the structure, and everything should be fine. Any things you want to see, you want to know about PyO3? We have like covered kind of basic stuff. I recommend you to take a look at this documentation. It's pretty nice. But already with what we have seen, you can create like strong bindings to your Rust code. And to be honest, I don't remember I actually needed more than what we have seen. But if you do want to know something else, feel free to ask. I will try to answer. Is that okay?
That's pretty good with me. That looks, yeah, fairly straightforward. It's nice.
Yeah, you see?
Yep.
So what else could I mention? We have seen like the results, the errors. Yes, important thing, just remember is like this pattern, map error, with a custom PyError type, for instance. This is something you will have to use. Some stuff I'm using is like the Py, always called the Py value error that I use most of the time. IO error is one very specific instance. But yes, I think it's it's okay. We'll just take a look quickly at the documentation just to see if there are additional stuff I could mention. Yeah, apparently you can also derive like some specific Python methods. I guess these are generating like the equal methods in Python. So yes, this framework is very powerful, and those I mean the crates you are building with PyOtree, you can easily publish them on PyPy. So if you need to craft like fast code other than word count and publish it to PyPy, you could just write it in Rust and then create the Python bindings. Okay, so if there is no other question, maybe we can just move to multi-threading. And I think it's going to be pretty nice already. So what could we do? Maybe let's say here we want to process several files in parallel, which would be a use case of multiprocessing, right? So how can we do? Else if, okay. What are we going to do? So first, we must be able to collect and to iterate over those arguments. So args.len, okay. And then else we remove this and we will just do for path in args. So this is just changing our, we don't need this met anymore. This just changed our implementation, which could have been even better from the beginning, by iterating over each command line parameter argument and doing a word count on each path provided. We can already test that. Okay, this I will close. It's not useful anymore. We are done with Python. So just watch this. I just go back to my workspace, my Rust workspace. I will deactivate like the Python virtual environment. This is not mandatory, I guess, but this is just like to reset to a fresh setting. So if I do cargo run, and then I do like cargo.toml, and then I specify another file which is example IO example src lib.rs. It should count for every file or not. What the hell? Could not compile binding example to show all linker arguments. Why is it trying to link with? Okay, interesting. So it's complaining because I don't have like the virtual environment, and it obviously doesn't find the Python library it needs to compile the Python module with. So two ways to fix that is to remove the Python from the members or just reactivate, I think, the virtual environment. I wasn't expecting that. What the hell? It's because, okay, even though I doing cargo run, it anyways compile all the stuff. Okay. What the hell are you doing? Let's try to do something. Cargo clean. Cargo clean just removes all the compile artifacts. Sometimes it's fixing errors. That's why I'm doing this. Let's see if it does solve stuff. No. Okay. Let's not focus on this error. We will not lose time with this. I will just remove the Python from the project members here. Okay. I don't know why this is happening. Probably there is a valid answer to this, but I don't want to lose time for the moment because this is not the purpose of what we are doing. Okay. Okay, stream did not contain UTF-8, and I don't know why. What is not containing UTF-8? Interesting. Probably there is an issue.
Yeah, I'm having the same issue. I was waiting for you to, see if it was. Yeah, I have the same
What
problem.
the hell?
My
What the hell is
guess
happening?
is that like the path, like the iteration on the path is incorrect. Like the args
What
are
does it
like.
give?
I don't. I haven't checked. I was just like, that was just like my guess.
This is like old school debugging. Okay. Obviously.
Yeah,
Because
it's
the first
running.
argument is what?
Oh, yeah, of course.
Yeah, it's our binary. Look how it is easy. Iterators are very powerful in Rust. So you just want to get rid of the first one, you skip one. Creates an iterator that skips the first n elements. Okay, it works. So now we indeed have a function, or at least a piece of code that is taking every path and doing a word count on it. So
instead of skip one, we can use like in Python in Python style,
like
you know,
like this?
Yep.
No, you can do that on slices, but there this is not a slice. This is
Okay.
a iterator.
Mm.
So this notation, this syntax, you can probably use it on a slice, but would be like this in Rust. But this is not a slice. We could do it. I will just mention it because you have asked. We could use this, but we have to create a vector from the arguments and use the slice of, or maybe we can just do toVect. No. So collect is a very, very powerful construct over iterators. I will just mention it because we haven't talked about it. Collect is actually something that transforms an iterator into something else. So here I could put like vector of string. I could eventually put a hash set of string. So you see, just transform this into a concrete structure holding data. It can do it because it iterates of a string, okay? If I would like to create a hash map, for instance, I would have to provide, for instance, here a tuple, maybe like, I don't know, creating a map, something here. But yeah, this is maybe a bit more this is a bit more like of advanced iterator use that we didn't talk about because we cannot talk about everything. But just to know that you can really do very powerful things over iterators in Rust, and I highly recommend to take a look at it. So we could have done what you said by first collecting into a vector and maybe doing this. No, doesn't work. Why it doesn't work? Args. A slice doesn't. Okay. But why this doesn't work? Yes, that's what I tried, right? Maybe this. Okay. You can use this. But why this is like suboptimal? This is suboptimal because here we actually collect a list of arguments just to iterate over it. So we create a vector in memory just for holding something we iterate over only once. So I would just prefer doing this because we just create an iterator, which is basically it costs nothing. And we say, okay, just discard the first element. So you could use like the kind of Python notation, but not with an iterator. You would have to use it through intermediary step of creating a vector, which of course takes more resources than just iterating over something.
Mm. And can we transform the iterator to a set, like in a Python set, to avoid duplicates?
Yes, we could do that. And we could do that just by doing this, what I did previously.
Okay,
This would create
hash set.
just a hash set.
Mm,
Hash
mm.
set is just like the Python set. This is exactly the same thing.
Okay.
So yes, this case you would remove duplicates. We could even keep yeah, but there we would have to do something else. We would have to put the skip here because it would take the first argument,
Mm.
because the hash set is not something which is ordered. So we have to skip the first argument, otherwise it's going to be somewhere in the set. We don't know where. It might be at position 0 or 1 or 2 or 3 or whatever, according to the number of arguments we have. So we have to skip it here. Maybe this implementation is not bad, as you said, because it removes duplicates. So this is possible. And if we specify twice cargo.toml, it should be taken only once, right?
Yes. Perfect.
So not a bad implementation. But we have to do the skip here, because this iterator is ordered, so we can safely skip the first one. And yeah, if I skip here, it will be a bug. Okay, so here we go, and we can eventually process every file in a separated thread. How do we create a thread? We do thread spawn, and spawn takes a fn once is a damn it, a closure that runs once. So a closure with no parameter. Then we put the thing we want to run in parallel, which is that. And it complains because we need to needs to return something. Oh, this was the issue, because thread.spawn returns a join handle. A join handle is something you can use to wait the thread to finish. And we are going to see what is happening if we don't wait the thread to finish. We are very likely missing output. Ah, yes, of course. Why is it complaining? Is because here we cannot like return early on the thread, because thread.spawn, the function must return what? The fn ones needs to return identity, or no, it doesn't return identity, but we have to specify what it must return. So this is like the closure, and we have to say we return result, custom error. And now it should work, no? Okay. Now it works. No. Closure may outlive the current function, but it borrows path. Okay, which is owned by current function. So because we put this data here, we have to use a specific keyword, which is move. And this is very specific to the threads. It's basically you move the ownership of this into the thread. Move converts any variable captured by reference or mutable reference to variable captured by value. So yes, basically it does some specific capturing on this and put it in the closure. So we cannot use it like the path after. It's like moving the path into the closure. And this we cannot look. This basically moves ownership inside the closure. You can see it like this. Because here you see we use the path by reference. So we use the reference in a thread to something which is defined in another thread. Because this for loop will run in the main thread. There we spawn a new thread, and the Rust compiler is just not happy about this, because of course what we have just tried to do is creating a kind of dangling pointers, because this pointer to path, if that thread changed, we would have like an unexpected value here. Is that clear for everyone? And that's why we need to move actually this into the closure, move the ownership into the thread, because otherwise here we create like a dangling reference to a string. And the Rust compiler completely prevents us from doing that. And in many other languages, you would just be able to do this. So we have just saved a bug at compile time. So look, sometimes we have output, sometimes we have not. Weird situation, right? This is pretty
on
simple.
my side, I have never output.
Yeah, this is simple. This is because we spawn threads, but we never wait for the output. We never wait for the completion of the thread. So we spawn, in this case, we have two files. We spawn two threads. The for loop terminates, and then the main program terminates. And then maybe the two threads are finishing after the main loop has finished, the main thread, and the results are just lost. So what do we have to do? We have to put the threads handle into a waitlist, let's say. This is a pattern that we find in many other languages, nothing crazy about it. Common multi-threading pattern. And what do we have to do? Yes, I'm out of the for loop. For each in the waitlist. So this is a join handle. This is called the stuff that is returned by this thread spawn object. So we just have to call join on it. What the hell? Okay, yes, I understand my mistake. This needs to be mutable. And this needs to be iter mute. But there doesn't need, yeah. Okay, so what did we do? Every time we spawn a thread, we put the join handle, so which is the value returned by thread.spawn, returning a handle on which we can wait for the thread to finish. So we add this into a vector called waitlist. And once we have created all the threads, we are waiting for them to finish. And we do that by creating an iterator of a waitlist, actually a mutable iterator, or rather a iterator over mutable items, which is the correct way. Then we iterate over every item, and for which expect like a closure. And the closure is just we wait on the handle and we call unwrap, which is actually join is returning an error. If we cannot join on the thread, we cannot wait on the thread. And what else? Cannot move out of, damn it. What is this? Cannot move out of, move occurs. Okay, great. Okay, maybe we cannot do that. We cannot iterate over this like this. Okay, this works. What we have changed here is that we have changed the way we iterate over the waitlist. Here into iter, at the difference of iter mute takes ownership over this vector while iterating. So since we just need to iterate over the waitlist only once, there is basically no interest to use iter mute, and it's just not happy about it. So let's use into iter instead of iter mute. Then it tells us that we don't use the results. So this is interesting to see that here our thread returns a result of OK identity or a custom error, but join is also returning a results. So actually here we have what? Here we have a result of result, and this is our result custom error. Okay, and there is like a thread error. I call it thread error, but join error. So it's like a result of results. So if we want to be all right, we first or eventually unwrap here, which is maybe not what you want to do. And finally, we can call this or not. Why? Can only be used in a closure. Ah, yes, because that's not a closure again. Because we are in a closure. Okay. Let's unwrap twice and we will fix that after. So there we unwrap twice. First the join error and second the custom error. And now we should be able to see like the processing of the two files. And the reason is because we just wait for the threads to finish before our main function returns. We have done multi-threading in Rust. Woohoo!
Yoo-hoo!
And yoo-hoo! Nice. I see you are enthusiast. And you can see here that we don't always get the same order. And answer is simple, is because of scheduling. We never know which thread is going to be scheduled and will terminate first. So that's why sometimes we get like cargo.toml first and lib.rs second, and sometimes it's the reverse. So just to finish, maybe this is the way, this is pretty ugly management because we unwrap twice, and unwrapping, as I said, is creating ugly panics. We can just make the tests. This is like example of Rust code panicking. So thread main panicked at my app 3831 because I'm trying to unwrap here the second time, and we get like custom error raised. So what would be the way to handle this gently? Would maybe to do here inspect error. Let's call it join error just to prevent any confusion. Println okay. And why aren't we happy about it? What the hell? Okay. Okay. Just fail to join thread. Anyway, this is enough. We just remove this. And then we can inspect the second layer of errors. And there we put like this will be the word count error, right? Again, same stuff. Mhm. So this shouldn't change anything. Info strings, string display is implemented. Yeah, this is a bit an ugly error, right? Okay. I know why. This is because I'm actually inspecting twice the same error. So, indeed, inspect error is something that allows you to inspect the error and return the results untouched. So I'm doing twice the same thing. So this is bad. This is very bad thing. For instance, if I put unwrap here, it would be okay. But this is not something we want to do. So we want to do what? We would have to refactor a bit the code because there we are in a closure and it's not very nice for error handling. So let's refactor the code. 4, join handle in waitlist. If let error the hash. Okay. One layer. Okay. Same. Okay. Yes, it's actually complaining because I still have this code block. And actually ownership is taken by the previous block. This is not needed in theory. Okay. Then if the thread just fail at joining, we can continue the loop. Then if the thread is okay, this is actually not the good way to implement that. We should do that this way. I'm sorry about this. So word count result, we can call this. Yeah, this is useless. Okay. So this is the proper way to handle this. A bit of revision. So here we have the word count result. And we can say word count result dot inspect error. Consider ignoring the value. Yes. If I forget half of the thing, so here I don't care about the result because anyway it's just an empty identity basically. So this is the way to make the Rust compiler happy and not have this error saying we haven't used the result. So now we should have like a better error management. And it tells us that it failed. But why does it tell us it failed twice? I think I have an idea. These are not the same error. Word count returned error. What? Ah, yes, because we have here as well. We should just remove this because we handle the error there. So this is useless. But we have, let's say, okay, this works as intended. We have no more panics. We have handled properly the results of the threads. And what is interesting, and which I think is lacking in Go, for instance, at least when I was doing Go, is that the thread can actually return any Rust return type, and you can somehow handle the result of a thread as if it was like a result of a function call, which is very convenient. The only thing you have to do before that is, of course, joining on the thread handle, and then you get you are able to handle the result of the thread function itself. So here the result of the thread function, is not very complex because it's just like the same result as a word count, thanks to, again, the question mark operator that returns early if word count is failing. So thread is returning a custom error in case word count is failing. And here we actually, in this block, we handle the error displaying of thread failure. If we would have more precision, we could eventually, instead of just returning a custom error, we could also add maybe the path to the, this is a string, so I return a string, as well as the custom error, so that we get a bit more precision on what's happening on which file. So we would need to map the error and return the path itself and the error. And why isn't it working? Okay. No. What is the stuff here? Yeah, it should return a result of type. Okay. Yes. This is there. We have to use that. Because there, E is just a IO error. Because word count return an IO error. So this is this one we have to transform to a custom error. So we use custom error from E. Okay. And now we are able to inspect the error and we get like both the path and the error if we want to do things like properly. Which would be a bit more convenient. Okay, there it's not happy because of what? Because it loses ownership of path. So here we would have to use a clone of path. But this is not very much an issue to clone when you return an error, because basically, yeah, on error you should do something, and this is not something that takes like lots of resources. So cloning on error, let's say, I would say it's acceptable. Okay, and now we get a bit more information. When the thread is failing, we say word count failed on the file name, IO error, which is better if we aim at counting on several files, because we get a chance to investigate what's happening. Okay, so this is like how we do multi-threading. We are running out of time now. If you guys want to know how you have to manage like mutexes and so on, we can just have a quick look to it, but that's up to you. Just tell me like how to manage shared resources between threads and how actually it's managed in Rust. Yes, no. Okay. So
Yes,
I
could
will
be
take this as a
interesting.
no. Okay.
No, could be interesting, but
Who said that, Alexei?
yeah.
Okay.
Because it's the last
So
time we have training with you. Slot
yeah,
for
anyway,
training.
I said that if you get question about anything related to Rust, and I will be happy to help. So don't hesitate to pass by the office, or yeah, just ping
Yeah.
me on the chat, and I
Yeah.
will help you if I can. Of course, like in 4 sessions, we cannot see everything, and especially starting from 0, it's yeah, it's a bit complex. Then I guess we are already reaching a level of complexity pretty nice, close like to a real program, and what you could do already like in advanced cases such as multi-threading. So yeah, it's pretty nice so far, and we have seen, I guess, a lot of things. And yeah, like shared resources between threads is again at a higher level, I would say. And we can just see quickly how we can do it.
I
So
think if I'm the only one who want to see it, I will look it on my side and will get to you if I have any issue.
okay, so if you want to look at it, just look at this structure, which is in the standard library. No, I don't have any. Again, could have put it in my bookmarks. Look at this structure. It's what I would have shown, arc, which is a reference counting pointer, which means that it you're actually sharing a pointer, sorry, thanks to arc, into your different threads, and it makes sure that the data you are pointing to is available until the last thread is used and is terminated, and this prevents like any
concurrency
issues that you have in C or C++ where you get some data freed while there is still some threads using it, causing use after free bugs. So this is a mechanism to prevent any use after free, and but also to manage accesses to the resources through mutexes and semaphores. So yeah, I think it's only mutex. Is this mutual exclusion? This is not something I use every day, so I don't remember the APIs. I think, yes, it just manages the read-write access in the same way.
Yeah, there is only references of mutex, none regarding
Yeah.
semaphore.
Okay, so you have to lock it. Yes. No. Yeah. This is there was something wrong about what I said. So this is like to create just the reference to an object. This doesn't manage the access to the object. You have to wrap arc inside a mutex or a read-write lock if you want to use it and lock it in your threads. This arc just manages like the allocation and the drop of the thread. So every time you instantiate or you clone an arc, it creates it increments basically a reference pointer to the resource you want to use. And every time like the resource is dropped, it decrements the counter. And when the counter reaches 0, the meaning that no one is actually using that resource anymore, the data can be removed freely. But yeah, the arc doesn't manage like the access to the resource. You have to use on top of an arc mutex if you want like a read-write lock in the same primitive, let's say, or a read-write lock that may offer more flexibility, where you can actually lock stuff for read or lock the resource for write.
Okay.
It depends what you want to achieve. And yeah, you have to combine both of them and in such a way, for instance. So you create a reference to a lock with a resource. And you see like very close, very small examples of how to use read-write locks with threads here. And I guess for mutex is exactly the same. So yeah, just like mutex and read-write locks don't offer the same primitive. You get a bit more flexibility with
a mutex.
read-write locks. Yeah, mutex is just like you lock whatever, either, yeah, you never know if it's for read or for write. Because read-write lock, the difference is that, for instance, you can lock for read at several threads at the same time. Let's say you have 10 threads sharing the same resources. If it's like for read, you can have like unlimited number of thread locking for read, but as soon as there is a write, it will prevent any read or any write, while mutex is just locking whatever. So you can always have one single thread locking the mutex. This is the difference between a mutex and a read-write lock. Read-write locks is more fine-grained, and it might be better if you have like algorithm, like a lot of read and maybe less writes and so on. But yeah, don't hesitate to ask questions and pass by my office if you need to know more. But yeah, I think we are done with the first iteration at LHC of the Rust training. Maybe I will do a small questionnaire, like what you like, what you dislike, and so that you can just help me improving on the stuff. And I will share you this over email. And yes, that's
there is a
over,
question
guys. I
about
hope you enjoyed it.
Andreas.
Pardon?
There is a question on the chat from Andras about
I didn't see.
the slice. Is it copy or not?
Oh, the question is like from 1 hour ago. So I will reply to Andras anyway. So whenever you use a slice, the slice is not copied. This is a pointer to the data in memory. But in this case, when we actually created the slice and iterating over the slice, we had to create a vector, which was maybe not necessary. And this is where actually some data are created. But whenever you use a slice, actually the only thing you copy is just a pointer on the stack. So it's not like a lot of data. You are not duplicating all the data which are in the vector. That's what I want to say.
Yes.
So I hope, Andras, you get this answer. So we are good. If there is no more questions, I will just stop the meeting and let's call it a day.
Yes, thanks
Thank you
a
very
lot,
much for that.
Quentin.
You're welcome. See you guys.
Thank you.
See you. Bye.
Thanks.